Hello everybody and welcome back. So in this next lesson we're going to continue from the regular expressions part 1, and in this case we're now jumping back into Houdini and Python, and I'm going to show you how we can apply that to sort of what we're currently doing. So I'm just going to pop open a Python source editor, and we're just going to use this and the Python shell just to kind of do our normal things. Obviously from this point, when we work on our saving script, that will then actually put this into sort of practical use, and so it'll hopefully make a bit more sense there. But I just want to go through some of the variety of options that we have to us when applying regular expressions. So I'm going to just import who, and then so in Python we need to import the regular expressions module, and the module is called re, just re. Okay, so that when we import re, we can now have access to all of the regular expressions functions in Python that allow us to basically analyze a string using a regular expression, and then it spits out a match object, and the match object we can then apply different functions on that to sort of grab bits of information from that match, or can loop over them, or whatever we want to do. All right. So now the main function we're going to be talking about, we'll talk about a few, but primarily I normally end up using only two of the sort of the main functions. Well, actually more about three, but there's about three of them that are more commonly used, or at least within my experience within Houdini. But it obviously depends on what you're trying to do. So the re.search, okay, is the main one for basically searching the entire string that you feed it for your regular expression. So let's actually just create a test over here. I'll call it my string, and we're just going to say this is a test string. Okay, so this is the string that we would be searching. Now normally we're not going to just do it with an explicit string like this. We'd do something like, maybe grab the scene path, or grab whatever a user has entered, and so it'll be stored in a variable, and then we want to search through that variable for some kind of regular expression. So let's go and prepare something here. So as I said before, we can take this into something like our regex 101. So this website. So let's go and just clear all of this and chuck in this as our string, and then we would build something. So we're just going to say, well, let's go and find all instances of t followed by a non-white space character, and maybe another single character or something. I don't know, just whatever. That should be enough. Okay, whatever it is that we want to grab. And then let's go back to Houdini, and I normally store this as a string, okay, because it gets really complicated if it's inside of here, because the regular expressions functions can get like really long, so it's really nice to keep it separate in its own variable, and then you just create, when you actually apply it, you just use your regex variable. So with this, and with in fact all of the functions, the regular expression that we're going to give it comes first, okay, not the other way around. You'd think a lot of the times, I'm going to feed it the string and then I'm going to feed it what I'm searching, but it's the other way around in this case. So we've actually feed it our regular expression and then the string that we're wanting to search. And then we also have another option, optional input, or optional argument, which is flags. Now I'm not going to use flags right at this moment. I'm going to go back and show you what the flags do just now. So for now I'm going to ignore that optional argument. Now let's store this in a match, okay, a match object, and then I'm going to print match. So we've got a string, we've got a regular expression that we know should find a few things in this string. Then we have, we're running our re.search function, storing that as a variable called match, and then printing that variable. Okay, so let's see what we get. So when I click apply, you can see that it prints this, which is a match object. So you'll see it's a Python object. It doesn't just print something like an index of where it found it or how many or some sort of list of things that it found or whatever. It specifically has a match object. And this match object has its own functions that can be applied to it, right? So we are going to talk about that just now and how to grab information from this. But we're going to first go through all of the functions that can actually run a regular expression and create a match object. And then we'll talk about all of the match objects and also the flags, because there are a few. All right. So re.search, what this is doing is it is scanning the entire string for this regular expression. Okay. Whereas our next one, and these are sort of used in conjunction depending on what you're searching for, is re.match. So match is only going to scan from the beginning of the string. Okay, so if it doesn't immediately match, right, which in this case it actually should, because it'll be T and then H, which is a non-white space character, and then I, which is just any other character. So it should find THI here, right? So if I click apply, it should print another match object. Now it prints these match objects when it does actually find something. Okay, so let's say it didn't find this. Let's say I had another letter at the beginning here. When I click apply, you'll see it prints none. Now it's not that there isn't a T, then a non-white space, and then another letter somewhere in here. There's one there. There's one there, and there's another one there. Okay, it should find those, but because we're running the re.match, it says no, this is not a match, because it's essentially trying to match the beginning of this entire thing. Okay, whereas if we did the exact same thing, even with that character there, but we swap this for re.search, right, it will now return a match object, because that match object has been able to find this within the string instead of match, which specifies basically, you know, I'm trying to match from the beginning. And basically the purpose of the re.match, the reason it's named match, is basically the regular expression you're building is then not designed to search for just a little section of the string, but actually you're almost trying to dictate the entire structure of the string. So remember our example from the previous lesson where we had a path to a file. So we have a drive, we have a path, we have a file, and we have an extension. We know that every path to a file is going to have all of those things. Okay, if it doesn't, it's not complete. We're missing the drive, or we're missing the extension, or something is missing. So in that case, we don't want to just search within the string. We want to search the entire string. We want to make sure that it matches from the beginning, because as soon as we hit a point where it doesn't match, well, then it's not a full path. Then it doesn't actually help us. Okay. Whereas if we're wanting to maybe go through the string and just replace every sort of instance of T and then something non-white space and then something, well, then we want to kind of scan the entire path, and it doesn't matter, the entire string, and it doesn't matter that it starts with something else. We want to search inside of the string. So that's the difference between search and match. Now, we also do have full match, which this means that it does need to match the entire string. So not even just the beginning, which re.match is going to start from the beginning. So if it finds in the beginning, so let's take our y away, re.match should find something because it does begin correctly. But re.full match will fail actually. Oh, in fact, okay, I guess maybe Python doesn't have the full match available. That's interesting, because full match is a function in regular expressions. So interesting that this doesn't have it. I'll see if I can figure that out and let you guys know. But basically, it doesn't really matter because I was going to say that full match is something that I never end up using because match is fine. You know, when you want to match it from the beginning, you're going to match the entire thing, including normally when you're doing a re.match, you won't include just like this. I'll often be very explicit about the fact that I want to the beginning of the string, so we put that upward arrow, and then a $sign at the end to specify that I don't want to make sure that like there's no additional characters. Let's say this was a path, and I've got my drive, and I've got my files, folders, and then my file, and then my extension, and then after the extension, you know, .bgo.sc, and then there's extra characters. That means that something's gone wrong. You know, this is not a valid string or a valid path if there's additional characters following it. So I will make sure that I specifically look for .bgo or .bgo.sc. You know, so I'll build in an optional kind of additional dot so that this counts as one extension. But from that point onwards, I'm going to put a $sign here to specify that that should be the end of the string. And if it's not, I want it to return a none, so not a match object, because it hasn't matched entirely. So because of doing it this way, basically you only need the match. You don't need that full match function anyway. Okay. So, right, so that's basically the big difference there between search and match. But we do have a bunch of other functions that also help us do kind of a little bit of other things with this rather than just returning a match object. So one of the really useful ones is split. Okay, so this, and that's kind of more what we would be doing with a much smaller regular expression here, where we're searching within this string for some kind of character or list of characters, and then we're splitting up our string based on that. Okay, so it's going to find every instance of that. It will remove that. That's important to know that it will remove it. It's the same as splitting by, let's say, slashes. When it returns the list of things that, you know, was like the list of strings between all the slashes, it doesn't include the slashes, that they've been removed. So it does that here. So we're doing re.split. We still feed it the regular expressions, and we still feed it the string, although this, okay, it obviously has our flags, which is an additional optional argument, which I will get around to, but it has an additional optional argument, which is max split. And that is just, we can, sorry, let me just put a comma in there. So max split like this, we can specify how many times it should split. And so it'll split from the beginning, but we can limit it. So we can say, well, only split 5 times and then stop. Okay. But if we don't include that, so if it's non-zero, then it will limit it. If it is 0, then it will never limit it. And so it'll allow it to continue for just split as many times as it possibly can. Okay, so now if we print this, you'll see this is the result we get. So we get a list which is strings, so it doesn't return a match object in this case. It gives us a list of strings which are everything that is split by our whatever is found by our regular expression. So the empty string is here because obviously we have THI at the beginning, which will match. So it's splitting nothing in the front here, so empty, from then S space IS A space, and then we hit the next kind of match. So it's finding a T, it's finding a non-white space character, and then it's finding another character, and so that's a match, and so it deletes that, and then it starts from here, T space S, and then it hits the next one, which is that. So you can kind of see here how it has broken it up into everything we wanted to split by, right? So for example, like a really good use of this would be if we've got a bunch of strings that have backslashes and forward slashes or whatever, we can very easily build a regular expression that looks for backslashes, forward slashes, doesn't matter which one, and we can specify that as a full list. And so every time it finds a slash, doesn't matter which direction it is, or doesn't matter if there's maybe 2 slashes, it just splits by that. So what you guys could do, if you really want to instill this information, is go back to our function where we built to fix the path and swapped all forward slashes. Well, we took all backslashes and made them forward. We took all double backs and made them forward. We took all double forwards and made them forward, and then swapped forward with whatever value we wanted, so that we could essentially unify all of our slashes. Well, you could do that in so fewer lines and much easier using regular expressions. Okay, so as a little challenge to you, you could always go back and replace the code in that function with a regular expression, right? And then you would use something like split, or in fact, actually, you'd use one of the other functions we're going to talk about just now, okay, to go and replace whatever we find with something else. But in this case here, we're just splitting it into a list of strings. Okay. So that's re.split. Oh, and like I said, we can go and put max split in here. So we could say go and split only 2 times. So then it's going to stop after 2. So it's going to split once, split twice, and then return the rest of the string. So it doesn't matter even there that there's a TRI, which would count. It just stops, okay, because we've limited it. Right. Then we have re.find all. Okay. Now this returns all of them, all right, like every match, and returns a list of the matches, but they are not match objects, right? So let's do this. So you see, remember this was it's basically the opposite of what we've just done. Because we are specifying something that has wildcards, what it returns, what it finds, when it finds, searches through everything and finds all of those matches, it returns those matches. This obviously wouldn't make sense if we specified something like, instead of that, we gave it just a literal match, like go find the word test, okay? Then all it's going to do is return test, and that kind of looks weird. You're like, well, yeah, that's the information I give you. Why are you giving me just that? But that's what you're asking it to do, is return the list of all of them. For example, we just go and give it the letter T and say go and apply, and then it's going to return a whole list of T's, and that doesn't make sense because But it's when we give it actual wildcards, we don't actually know what's going to come out of this, and some wildcards that we can give it are even more sort of broad than others. We could be very we can go give it a dot and then say anywhere between 3 and 10 characters afterwards, and then sort of see what that returns. So you can kind of we would need to between 0 and okay, well, anyway, so basically it's gonna, if we give it these kind of variables, it's going to return what it is that it found. And so if we know we're sort of looking for a T, but we're not sure what's going to come afterwards, if we specify these rules correctly, then it'll go through here and find all of those and then spit them out in here. Okay, so that's find all, which again takes the regular expression, takes our string, and then an additional optional flags, right? And then we also have find iter, and this just returns an iterable. Okay, so it's an iterator object which we can then with an iterator you don't want to loop it, you actually want to grab, because it would be better to just get all and then loop through them, but here we could specify, for example, 1, right? This should hopefully work. Okay. It'll be a separate sub function in the match, sorry. But basically it's going to go through and find them and then create an iterator object, which we should be able to loop over it. So for let's say for x in match object, and then if we print x, right? Okay, there we are. So it's a list of match objects basically, but it's iterable. Okay, so now we could go to each match that we found and do something to it, right? Which I said we're going to get around to what we can do with our match objects just now. So you could, inside of a loop, we could do that. Okay, so then that's finding each one and allowing you to do something instead of finding them all and returning them. And then our final one, and I say final, there are obviously more, but these are the ones that I found useful, and I don't want to confuse you with like tons of ones that are very outliers and like we don't use them often. I'm just showing you the ones that I found to be useful. So re.sub. So this is to substitute something. It's essentially a string replace function, but it's using regular expressions, which is obviously very, very powerful. So this takes an additional argument, which is the replace argument. So we're saying go and find this inside of here, but what we do, our second argument is replace, which is REPL if you want to do it with a keyword. But we could just say, I'm just going to give it foo, right? So you give it something to replace with, something to replace, and then the string to search, and then it also takes flags as an optional input as well. So then instead of doing this, we would just say print match, right? And then you'll see over here that it's gone and replaced every match that we found with that matches that is now replaced with foo. Okay, so now it says foos is a foot, foo, okay, whatever. So really bizarre things that you can do there, but yeah, I mean that would obviously be a really good way of replacing, let's say, all backslashes and forward slashes and double slashes with just one unified character. Okay. So now that we've got a match, right? Now you see, by the way, sub just returns the new string with all of it replaced. So not all of these do return match objects, but let's go to one that does. So for example, we're going to say re.search, and then we feed it that. So this will return a match object. Okay, I'm going to hit enter just so we can give some space, and we see that we're getting this Python match object. So what functions can we apply to this, right? So what we can do is so one of the most useful ones is match.group. So this is essentially opening up this this match object into the list of groups. Basically, it's the equivalent in regular expression, like regex 101, of this tab over here, where we had the list of full matches as well as any subgroups that we create, right? So if we go and specify this as a group or something, then it is going to specify the full match as well as the actual group name, right? So let's jump back here. So if I give it group with nothing, no arguments, then what it's going to do is return the full match. Okay. Now remember, search doesn't loop, doesn't iterate, right? We have to specifically tell it to loop. So this is finding just that first one, and then it exits. Okay. So even though it will scan the full string, so if it didn't find one here, it would keep going. It doesn't have to match at the beginning, but it will only find the first one. So that's important to note, right? And we can see that because here when we return group, it's going to return the full match that it found, okay, which is THI. Now, if we feed it a number in here, for example, then it's going to return that group index, okay, which in this case is just going to return, so 0 will return the full match, and then 1 is going to error because it says there is no such group. And that's because we haven't given it any actual groups, right? So we can go back to regex 101 over here and copy this, right? So when we're specifying an actual group name, okay? So we'll replace that in here, right? And now when we return 1, it's returning group 1. So 0 is the full match. For example, let's say outside of this, we've maybe put dot star A. Okay, so it's gonna after our T and then non-white space and then some character, it's gonna put that in a group, but then it's gonna keep selecting until it hits an A, right? And that's outside the group. So when we print the full match, which is either 0 or just an empty string, then it's going to specify this is a, and then stop there. But and that is the full match. So if we go 0, it's going to return the full match. But if we tell it 1, then that's the actual first group in our list of groups. And so it returns THI, which is this group. Okay, if we had multiple groups, it is basically a way of selecting it by index, but it's just important to note that it is 0 based, except that 0 is the full match. So 1 is the first group and 2 is the second, and so on, right? But what we can also do in here is specify the actual group name. So we can call them by name, and because in this case we called our group my group, we can now specify the group name, and it will also return just specifically that group. Which is why when we did our example with the paths, you say drive and path and file and extension, and then you can actually specify, you'd say match.group ext to check what the extension is. Okay. So, yeah, right. Okay. And besides that, we can also do groups like this, and this then returns a list of all group matches. Now, it's important to note that if we don't give it a group, right, so if it only had the, if we just take all of this away and so go back to our original and try and do this right, it returns empty. So this does not return the full match, it only returns the groups, the list of groups, okay? So if I go back to where I had my group, and when I print groups, you'll see that the full match is not here. So even though we are matching .*A, which will be these characters up to there, those that I've got selected will be included in .*A, but because they're outside of the group, they do not get included in this list. Okay, so it's only every group. We could, for example, go and include this in a group, and then it would return those two as separate groups. But then the one is callable by name because I've given it a name. So group, my group, and I can call that. But if I want to call the other group, because I haven't given it a name, I have to specify group 2. Okay, so I hope you're seeing sort of how we can work with groups. And another way of working with groups is to grab a group dictionary, right? So, but this is only going to return a list of groups that actually have names. So in this case, my group does get listed, but this group is ignored from this, even though it will be in our list of groups, which has 2. This only has 1 entry because this one does not have a name. And we have to specify a name for this one in order for it to actually appear in both the groups and the groups dict, okay, which is going to return the dictionary of all of the groups with their, so the key is the group name and the value is what strings were, well, what part of the string was grabbed. All right. And now I'm going to go talk about the flags, right? Because in addition to this, we can also specify some extra kind of rules to this, right? So one of there are a whole list of rules like flags. You can go and search for them if you want, because a lot of them just, I mean, especially when you're just starting out, you don't really need them. I mean, honestly, the only ones I ever use are these 2 that I'm going to show you now, and in fact, the one of them is kind of rare as well. So obviously, it depends on what you're doing. If you're doing much more advanced coding than this, then absolutely you may need it. And regular expressions has so much that you can possibly do with it. But to keep it simple, though, we have we have to actually specify flags equals, right? So we give it the keyword, and we're going to say re dot, and then it is in all capitals, ignore case, okay? Which is a flag that specifies to ignore the case of something. So let's go and in here, for example, if our A was capital over there, then we'd get a different result, right? But in this case, because we're ignoring case, we don't get a different result. If we took that away, then it says there is no group dict function for none type, because match is obviously returned none, no match object, because it's found THI which is our first group, and then it starts selecting until it finds a lowercase a, but there are none in the entire string, and so it fails completely, right? Or if there was an a, let's say over here, then of course it would find that, but our second group is much larger because it's got to go all the way until it finds a lowercase a. However, if we had that flags equals re.ignore case, okay, then it's will specify, okay, well, it'll still go to this a, but that's not because this one is ignored, it's because it's greedy, right? If we told it to be lazy, then it would, sorry, not a question mark there, just here. So dot star but question mark, say be as lazy as you can, and then go and select an a, but ignore case. So now it'll go and select up to that capital A. Okay, so that's what we do with ignore case. And in fact, as far as I know, there's a shorthand where you can say just re.I, and I think it does the exact same thing. Yeah, so you can specify re.I, and then there is also re.multiline, okay, or re.m, and this basically considers every line is considered to be a new string, which means that if we do have a multi-line string that we're feeding it, right? So if we actually have like a /n in there, then when we try to match using, remember I said we could specify a beginning of the line with a upward arrow, or we can specify the end of a line with a $sign. That if we don't have multi-line active, then it's only going to apply at the end over here, right? So let's say we wanted to go and select just an n, but an n that is followed by the end of the whole string. Okay, so $, right? Now let's just take this away, and I'm also going to take this /n away, right? So just our normal string, and we want to grab $. Now there are other n's in the string, but it's not going to grab any of them because the second part of this does not qualify as a match. Okay, so now obviously our group dict is not going to return anything, but we can just say group so that we can see what gets grabbed, right? So that's our n. Obviously it's hard to tell that it's the one at the end, so let's maybe go and put maybe dot. I'm just going to put dot just so we can kind of see that it's the f n at the end here. It's not this in or an. Okay, so it specifically grabs the fn because it's got this end of string at the end, right? Now what if before this after this n, what if I go and put a /n, which means that this is a new line? Okay, so technically that then should grab this, right? So but it won't, because it's not a multi-line string. So even though we technically have two lines in this, and so this one should count because it has a something before it and then an n and then the end of the line, it's not multi-line. So we can say flags equals re.m for multi-line, and then it's going to return in. Okay, so well, that's the full match, because obviously, like I said, search is finding the first match. So it's finding this match and then it's stopping. If we told it to grab all of the matches, like re.find all or whatever, then it's going to find this one and this one, because now both of them qualify. The fn followed by the end of the line, and here there's an in followed by the end of a line, but that's because we're telling it to count this as multi-lined. Okay. All right, so I hope this isn't too confusing for you guys. If you haven't done it before, it can be a little bit overwhelming, but try to just persist with this. It is incredibly powerful, very useful, and honestly easier than it looks. Once you play around with it a little bit, it just starts to make sense. Maybe don't deep dive into this, like just do some basic things with it first, because once that makes sense, then building on that foundation, the rest is really easy. It's the same with any coding. I always say that once you kind of know the basics of it, then learning a bigger vocabulary, so a wider variety of functions, is just really easy. You don't even have to go and memorize it. Just use these help files, go and read up on regular expressions. Okay, but in this case, we're just going to use some simple things to check the name of our file and the path of for our file when we're working with saving our scene. Okay, so like I say, if this isn't making sense yet, when we work on our save scene script, you'll actually see it in practice, and so it might make more sense then. And if you really want to challenge yourself, I would suggest, as a bit of a exercise for this week, is go back to our script where we fixed the path and go and swap it for a regular expression function. Don't forget, you'll need to import the re module at the top, and then you can use re.sub is a pretty good one to do, or you could do re.split, and then you can split it and then reassemble it if you want to. It's up to you. And then obviously you'll need to get the syntax right for the regular expression. So if you've got your string with a so a forward slash and a backslash, so you see, you come in here and you build a test string that kind of has all of the potential things that could go wrong. Like you've got some forwards, some backs, some double forwards, some double backs, and instead you want to go and replace them all. Well, you go in and build your expression here. So then you go and say, okay, well, I want, well, what if I want to just grab any like non-word character? Maybe that'll work, So then we say, okay, non-word, yeah, sure, non-word grabs them all, right? But what if there's a space? Well, it does also grab a non-word. So you need to be careful to not only put in ones that you're looking for, but actually deliberately put in things that you're not trying to hit, to make sure that you don't grab them. See, there's like an @ sign. Well, now non-word is not going to work. So I now need to specify, okay, well, maybe, I want very specifically to grab a forward slash, or I want to grab a backslash. Okay, so now those are both, but now we don't want to grab these individually. You want to grab multiple. So, we then go, okay, so, grab any number of them, or you could specify exactly, 1 to 2 of those, or whatever it is that you want to specify. So you can use everything I've just shown you to build your own function to then go through and grab any of those arguments that you would potentially find, and then go and either re.sub them for the user's given slash, with obviously forward slash as a default, or you could split it and reassemble it. It's up to you. Okay, so thank you, everyone. I hope you enjoyed regular expressions, and now we're going to move back into doing our tools. So we're going to work with the saving scene script, which is going to be here in our shelf. Okay, I'll see you in the next lesson.